and welcome to space. The head of the European Space Agency says he would like to build a permanent base on the moon. It's an incredible plan, and we're here in Cologne at the European Astronaut Centre to meet some of the people who might make it happen. So how do you build a base on the moon? Let's have a look. This is the target, the place where half a century ago Russians first landed and Americans first walked. Today the moon is the focus of fresh ambition from the Director General of the European Space Agency, Jan Woerner.
My intention is to build up a permanent base station on the moon. Meaning that it's an open station for different member states, for different states around the globe.
It's one small step for man.
Mankind has never had a permanent lunar presence. But the Apollo era showed that with the right commitment, giant leaps are possible.
We did this in the 60s within a decade, and today we're, in terms of development, technology development, we're much, much further ahead. Of course we can do it again.
The idea is that the moon base would follow the International Space Station as a global project.
So it will be the Americans, it will be the Russians, it will be the Chinese, it will be the Indians, the Japanese, and even more countries with smaller contributions.
For the moment, the concept is short on detail but high on enthusiasm. Earlier this month, the European Astronaut Centre in Cologne hosted a workshop on how to build a permanent lunar village. One key message was that mankind can use the metals, minerals and water ice found on the moon.
La Lune est pleine de ressources. Au pôle de la Lune,
the moon is full of resources. We've found ice at the lunar poles, and we've found areas that are in almost constant daylight. And these places can offer us resources that we can use for construction and to support the lives of the astronauts on this moon base.
La vie des astronautes dans cette base lunaire.
Principal threats to any moon base are solar and cosmic radiation, micrometeorites and extreme temperatures. To counter those threats, Irishman Aidan Cowley is working on using the lunar soil itself to build protective domes.
One of the ideas we had is, could you potentially use this material to 3D print a habitat structure or a building element on the moon? And we think you can. Our concept is that a rover would land on the surface of the moon, would inflate this inflatable dome or this bladder type system, and then around that the rovers then begin to construct a dome that would provide the protection for the astronauts inside the dome. So you put down a layer of dust, you sinter it, and you put down another layer of dust, you sinter it again, and you keep repeating this until you build whatever structure you're trying to build.
Of course, it's not easy to go to the moon to test out new ideas. So scientists look for places with rocks and dust that are similar, like here in the Eiffel Volcanic Park near Cologne.
Ici, nous avons un équipage et
Here we have equipment and instruments with which we want to measure the composition of rocks. And we want to validate how these instruments work by using rocks which are very close to lunar or Martian rocks, volcanic rocks.
Yeah, I see. Can you put your hand next to the reference rock?
In this scenario, one of the researchers plays the role of an astronaut on the lunar surface and his colleague guides him from a distance.
Okay. This is captured.
Yes.
They want to know how the astronaut interacts with the base station and how the spectrometer on their mock-up lunar lander identifies minerals that could be useful for building and sustaining a moon base.
I'm the astronaut in this simulation, so she directed me to a sampling site she wanted to sample and told me when I had to come back and measure the sample in front of this little laboratory.
Now I can see him on that view.
Move. Yeah.
The telescope and now?
The light conditions are very good at the moment, so you don't need to use any alternatives. So it was really easy to get a good signal, yes.
You're happy?
Yes, I'm very happy.
So we're going back, and this time we're planning to stay. The commitment to the moon village from the head of ESA sends a powerful message. However, it could be 20 years before technology is ready to make it happen.
So there's a huge development cycle that has to be started again, from developing the rockets that'll take us into orbit, that'll transfer us to the moon and land us on the moon, and then of course the bases that we'll live in on the moon. It's the entire suite of technology that we need to develop.
ESA is not alone. The Chinese plan a lunar sample return mission, Russia is developing a robotic lander with ESA support, and NASA's Orion capsule with an ESA service module should fly around the moon before 2020. And that diversity is key to Jan Woerner's vision.
The advantage of the idea of Moon Village is that we don't need a big amount of funding at the beginning. That means we can start with a small landing mission, which many countries are already planning, up to a huge investment, for instance, for some telescope, radio telescope on the far side of the moon. So it's a multiple uses by multiple users, but a single place.
That place is the moon. Scientifically interesting, technologically challenging, and a superb testing ground. Away from the moon now and to Mars, and next month the ExoMars mission sets off towards the red planet, looking for signs of methane. One of the top scientists behind the project explains why in Destination Mars.
Hello, my name is Anne-Karine Vandel and I'm in charge of the Nomad instrument on board the ExoMars mission, which will be heading to Mars soon. Inside the box, there are 3 spectrometers which will analyse the composition of the atmosphere of Mars, and methane in particular. Methane is important because on Earth it's linked to biological processes. There hasn't been enough tangible evidence to be able to say there is life or there was life on Mars. Different instruments on different missions have already observed methane on Mars. Curiosity, Observations from Earth, or PFS on Mars Express. But there are question marks above all of these measurements. And so ExoMars will resolve the methane problem once and for all by using instruments which are dedicated to that gas. So the stress is rising in the team. You have to imagine that an international team has been working on this instrument for several years. We're waiting for data, we're waiting for our instrument to be in orbit around Mars. So the stress in the coming months is going to be intense.
That's all for now. Next month we're behind the scenes at the launch of ExoMars in Kazakhstan. See you then.